Good day, 11th STEM. Welcome to the first video for the subject General Chem 1. I will discuss formulas and names of compounds for Module 2. So, before we continue with the activity, I will first discuss this table. We have cations of metals, alkali metal cations. These ions have +1 charges. We have the lithium, sodium, potassium, rubidium, and cesium ions. Alkaline earth metal cations, these are the +2 charges. Magnesium, calcium, strontium, and barium ions. We have aluminum, which is a +3. And then we have anions of non-metals. So check out the ending class. It changes fluoride from fluorine, chloride from chlorine, bromide from bromine, and iodide from iodine. And then we have the -2, oxide from oxygen, and sulfide from sulfur. And then we have the table for common polyatomic ions. There are only 7 here. There are a lot of polyatomic ions. I would love you to know more about polyatomic ions. Then we have the Greek prefixes. We have the mono, the di, the tri, tetra, penta, hexa, hepta, octa, nona, deca. You are very familiar with this. And then we have the next table. These are metals with variable oxidation numbers. Older name is also called the Latin name. So example, we have iron 3 and iron 2. This iron, the 3, the Roman numeral 3 and Roman numeral 2 represents the charges, +3 and +2. So the one with the higher oxidation number had an ending name of IC, ferric, and the one with the lower oxidation number, the ending name is OUS, ferrous. It is true with the other ions here. Okay, for copper 2, copper 1, cobalt 3, cobalt 2, tin 4, tin 2, lead 4 and lead 2, mercury 2 and mercury 1. There is a note here. Mercury 1 ions always occur bound together in pairs to form Hg2 +2. Terms to remember. Oxidation number is also called oxidation state. It is the total number of electrons that an atom either gains or loses in order to form a chemical bond with another atom. Metals lose electrons while non-metals gain electrons. Positive ions are called cations and negative ions are called anions. And then let's go to the activity. Activity 4, binary and polyatomic compounds. So binary, a unique compound. In writing the name of a compound, write first the name of the cation followed by the name of the anion. For example, number 1, we have beryllium bromide, sodium oxide, calcium fluoride. Take note of the spelling of fluoride. UO, not OU. B, boron phosphide. Aluminum oxide. Okay, so you were given the formula, you write the name. Next, you are given the name, you write the formula. Okay, we know, class, that atoms are neutral. So that means the charges should be equal or balanced. That means the positive and the negative charges should be equal. That is why in writing formulas, we need to have this crossover method, or sometimes we call it uh, cross multiplying. Okay, it's the same. Now, rubidium is plus 1, oxide is minus 2. Usually, the oxidation numbers are given, but if it is not given, you need to look at the periodic table. Now, so we cross over. This 2, we crossed it to rubidium, and this one, we crossed it to oxide. And then we copy Rb2 and O1. But there is no need to write 1. Without writing 1, it is already understood that oxide is 1. So the correct formula is Rb2O. Now, we'll see if it is balanced. 2 times plus 1 is plus 2. Plus 1 times minus 2 is minus 2. So it is equal to 0. That means our formula is correct. Next, we have calcium iodide. The same process. Calcium is plus 2, iodide is minus 1. We cross over the oxidation numbers. 1 is written here, cross to calcium, and this 2 is cross over to iodine or iodide, and then we just copy CaI2. So 1 times plus 2 is plus 2, 2 times minus 1 is minus 2, plus 2 plus minus 2 is equal to 0. That means our formula is correct. So you can always check. Cesium, okay, the same process. Magnesium iodide, the same process. Now, for number 10, lithium chloride, look, the charges are equal. Okay, plus 1 and minus 1. There is no need to cross over. There's no need of that. What you will do is just copy the symbols, LiCl. That's that. Okay, the same with magnesium plus 2, oxide minus 2. Similar charges, number of charges. So just copy MgO. Okay, that's clear. Let's go to binary covalent compounds. These are for nonmetals. Okay, so we will write the name. OS is osmium, and there are 4 oxide, tetra oxide, xenon trioxide, phosphorus trifluoride, sulfur tetrachloride, bromine pentachloride, krypton. Okay, the next is writing formula. Krypton, okay, krypton is Kr, difluoride F2, xenon Xe, hexa 6 fluoride, sulfur trioxide, carbon dioxide. Very easy. And of course, dinitrogen pentasulfide, 5 sulfide. Let's go to ternary compounds. Ternary compounds means there are 3 elements in the compound ternary. So we have tin bisulfide 2. This is the formula. So from this formula, we know that the subscript 2 here refers to tin. That is why the answer is tin. And then to put this number inside the parentheses, Roman numeral, okay, Roman numeral 2, and then bisulfide. And then the other name using the Latin name would be tin is tin has two oxidation numbers, the +2 and the +4. So we are in the +2, so it is lower. So the ending would be OUS. So it is stannous bisulfite. There is no need to write this Roman numeral because the OUS already shows that or indicates that it is the lower oxidation number. And then we have magnesium dihydrogen phosphate, ammonium nitrate, silver phosphate, cobalt. The subscript here is 3. That means it is from cobalt. So cobalt 3 nitrite. Cobalt has +3 and +2. So this is 3. It is higher oxidation number. So it is cobaltic. It's ending in IC, nitrite. And then potassium perchlorate. Now we will be writing the formula. So this is +1 -1. So similar charges, just copy KClO4. And then lead 4. The lead 4 here, that means the lead has an oxidation number of +4. Okay, so the other name here is plombic hydrogen phosphate. Now lead 4, this is hydrogen phosphate. So a crossover, this 2 is from this oxidation number of hydrogen phosphate. This 4s, the oxidation number of lead. So remember, class, that we need to have this parenthesis. Use a parenthesis if the ion is a polyatomic ion and the subscript is more than 1. Okay, so the subscript is more than 1, because if the subscript is 1, there is no need for this parenthesis. Okay, so we have copy Pb2 parenthesis HbO4 parenthesis close parenthesis 4. Okay, so that is lead 4 hydrogen phosphate or plumbic hydrogen phosphate. So aluminum sulfate, the same process, the same with number 9, iron bicarbonate, iron 2 bicarbonate, and number 10, barium iodide. So that is the end of writing names and formulas of compounds. I hope you understand better how to write a name and formulas of compounds. If you find this video helpful, please like and subscribe. Thank you very much for watching.